Hi guys, you are welcome to your favorite learning channel. My name is Oluwatoyin. Today we are going to dig through a topic in organic chemistry called alkyne. Alkyne. What are alkyne? Alkyne are unsaturated hydrocarbon having triple bond in their structure. Alkynes are unsaturated hydrocarbon having triple bond in their structure. Then the triple bond in their structure consists of a very strong sigma bond and two relatively weak pi bond. It consists of what? A strong sigma bond and two relatively weak pi bond. Then alkyne are also known as acetylene. Alkyne are also known as acetylene. Then alkyne has a general formula of CN H2n minus 2. So from this general formula, you derive the molecular formula for members of alkyne. Like I explained in my last video, that members of hydrocarbon starts with prefix met, et, prop, but, pent, ex, het, hot, non, and dec. So all you need to add to those prefix is their what? Is their suffix, which is their name ending. So the first member should be met. Start with met, with prefix met. The second member with et. The third member with prop. The fourth member with but. The fifth member with pent. The sixth member et. Then the seventh member is et. The eighth member ot. The ninth member non, then dec. So you derive their name from this prefix. So all you need to do to derive name for alkyne member is to add the name ending ine, met-ine, et-ine, prop-ine, but-ine, pent-ine. But this one does not exist under alkyne. Methyne does not exist under alkyne. So there's nothing like methyne under alkyne. Why? Because the molecular formula for methyne consists of only one carbon atom, and the triple bond, which is ine, must exist in between two carbon atoms. The triple bond, which is ine, must exist in between two carbon atoms. That is why methyne does not exist under alkyne. So let's look at the physical properties. So in today's topic, I'm going to discuss about the physical properties of alkyne and the method of preparation of alkyne. So let's look at the physical properties of alkyne. Physical properties of alkyne. So what are the physical properties of alkyne? Number one, alkyne with 2 to 4 carbon atoms are colorless and odorless gas, except ethyne with sweet odor. Alkyne with 2 to 4 carbon atoms are colorless and odorless gas, except ethyne with sweet smell. Then the fifth member to the 16 members are waxy liquid. They are waxy liquid. While other members are what? Are solid. Other members are solid. Then number two, alkyne members produce a smoky luminous flame. They produce smoky luminous flame. Smoky. They produce smoky luminous flame due to high carbon content in their molecules. They produce smoky luminous flame due to high carbon content in their molecule. Then they have high melting and boiling point. That's another one. They have high melting and boiling point due to high carbon content in their molecule. And lastly, their melting and boiling point increases as the number of carbon atom increase, or as their molecular mass increases. As the number of carbon atom. So let's talk about method of preparation of alkyne. What are the method of preparation of alkyne? Number one, method of preparation of alkyne. That is, how can we prepare alkyne members? How can we prepare alkyne members? The first method is called vicinal dihalide. Vicinal dihalide. Vicinal dihalide. So what is the meaning of the word vicinal? Vicinal means when two adjacent carbon atoms, contain halogens. When two adjacent carbon atoms contain halogens. Then the meaning of dihalide. The halide is a binary chemical compound of halogens ions. It is a binary chemical compound of halogens ions. So since we know that halogens carries what? Negative charge. Negative charge. So when halogens react with a less electropositive, a less electronegative atom or radical, or react with what? A highly electropositive radical or atom. So it will give us what we call halide. That is reaction between halogens ion and less electronegative radical or atom, or highly electropositive radical or atom will give us what? Halide. Let's take for example, hydrogen is what? Is an electropositive. Hydrogen is an electropositive because it carries what? Plus one, that is the positive ion. It carries positive ion. So when hydrogen, which is an electropositive, reacts with halogen, chlorine is what? Chlorine is a halogen. Chlorine is a halogen. Then what are halogens? Halogens are what? Are group 7 elements. They are group 7 elements. So when hydrogen reacts with what? With halogen, it will give us what we call hydrogen chloride. So hydrogen chloride is what? Is an halide. Hydrogen chloride is an halide. So another example, when a metal, which is sodium is what? Sodium is electropositive. Sodium is electropositive. So when it reacts with what? With chlorine or any members of halogen, it will give us what? Sodium chloride. So sodium chloride is what? Is an halide. Sodium chloride is an halide. So when we say dihalide, means two what? Two halides what? Molecule. Two molecules of halide. Two molecules of halide. So the vicinal dihalide means that two halogens attached to the adjacent carbon atoms. When two halogens attach to the adjacent carbon atom. So let's come back to this the first method of preparing alkyne. Let's come back to the first method of preparing alkyne. So the vicinal dihalide, from vicinal dihalide. So the root of this preparation is alkane. Alkane. It is derived from what? Alkane. For you to prepare any members of alkyne under vicinal dihalide, your starting point or your starting material will be an what? Will be an alkane. So therefore, when halogens react with an alkane molecule, it will give you what we call alloalkane. Allo is from halogen, then alkane, an alkane member. So to prepare members of alkyne, don't forget that the second member of alkyne is called what? Is called ethyne. The third member is called propyne. The fourth member is called butyne. The fifth member is called pentyne. So for you to prepare members of alkyne, you use what? You use members of alkane. You use what? A corresponding member of alkane. So for example now, if you want to prepare ethyne, you use what? You use ethane from what? From an alkane. So the starting material is called what? Is alkane. is called alkane. So we use what? We start with what? An alkane molecule. Now I want to prepare ethyne. So we prepare members of what? Of this alkyne by using what? Using a strong base. Using what? A strong base. Using a strong base and soda amide. And soda amide. So you use a strong base, that is, reaction will take place in the presence of what? A strong base and soda amide. So let's prepare the first member. We want to prepare ethyne, which is the second member of what? Of alkyne. To prepare what? Ethyne, which is the second member. Then don't forget that the general formula for alkyne is CnH2n minus 2. This is the general formula for alkyne. So what will be the molecular formula for ethyne? We want to prepare let's prepare ethyne. Preparation of ethyne. So ethyne is in number 2. Like I said in my last video that the first member, which is methane, does not exist under alkyne. Methane does not exist under alkyne. So the second member, number 2, is what? Is ethyne. Number 2 is ethyne. So if I substitute these two into my general formula to derive the molecular formula for ethyne, substitute these two into this general formula. C times 2 will give me C2. Then 2 times 2 is 4. 4 minus 2 will give me 2. So the molecular formula for ethyne, is C2H2. The molecular formula for ethyne is C2H2. Now to prepare this ethyne, you use what? A corresponding alkane. You use a corresponding alkane. Your starting material must be what? Must be an alkane. So if I want to prepare ethyne, I will use what? Alloalkane. I will prepare it from alloalkane. Alloalkane. Then you want to prepare ethyne, so you use alloethane. So it will now be alloethane plus, don't forget that the reaction will take place in the presence of what? Of a strong base. Now give me examples of strong base: potassium hydroxide, sodium hydroxide. So but this time around I'm going to use potassium hydroxide. So in the presence of KOH and soda amide. What is soda amide? The chemical formula for soda amide is NaNH2. The NH2 is the amine from the soda amide. So let's take the structural formula for this alloalkane, sodium hydroxide, and what? And soda amide. And let's see how we are going to balance our chemical equation to derive what? Ethyne. Don't forget that we are going to what? We are going to ethyne. We want to prepare ethyne, but we are preparing ethyne from what? From alkane. So alkane with what? A single bond, while ethyne with what? With triple bond. Then the alloalkane. Let's first draw the structure of ethane. Ethane is the second member of what? Of alkane. Then alkane has a general formula of CnH2n plus 2. So to derive the molecular formula for ethane, being the second member, so my N will be 2. C times 2 will give me C2. 2 times 2 will give me 4. 4 plus 2 will give me what? 6. So it has 2 carbon atoms, then plus an halogen. Now let's take the structure for this molecular formula. Then we are going to add what? 2 halogens. Halo means what? Halogen. Halo is derived from the word halogen. So we replace 4 of these hydrogen atoms. We replace 4 of these hydrogen atoms with two halogens. Now I'm going to remove 4. I'm going to remove 2 out of these 6 hydrogen atoms remain 4. Then I will replace the remaining two hydrogen atoms with what? With halogen. So let me use chlorine this time around, then replace with 2 chlorine. Now let's draw structure. It's still an alkane, but it is an alloalkane because I've added what? Halogen. I've removed 2 hydrogen atoms. I've removed 2 hydrogen atoms from 6 hydrogen atoms and replaced with what? 2 halogens, which is chlorine. So let's draw structure for this molecular formula. So we have 2 carbon atoms. So join those 2 carbon atoms together with chemical bond. 1, 2. Then each carbon atom must be surrounded with 4 chemical bonds. 1, 2, 3, 4. 1, 2, 3, 4. Then fill with what? 4 hydrogen atoms. Then don't forget that from this word Vizina means that when two halogens attach to the adjacent, that is the base. When two halogen, Vizina means when two halogens attach to the adjacent carbon atom. So these are the carbon atoms. So the adjacent part of it will be down. So we are going to attach these 2 chlorine to the adjacent side, bringing chlorine here and chlorine here. So they are the adjacent side. Then we now fill what? The remaining chemical bonds with 4 hydrogen atoms. 1, 2, 3, 4. So now the next stage, because the process says that the reaction will take place in the presence of what? Of a strong base. So we are using potassium hydroxide as a strong base. Now we are using potassium hydroxide. So let's add potassium hydroxide, KOH. So addition of KOH to this structure, what will happen? So you remove dihalide. Then another name for Vizina dihalide is dehydrohalogenation. 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 So dehydro, De means remover. Hydro is hydrogen. Then halogenation, that is halogens group, like chlorine, bromine. So it shows that dehydration means removal of hydrogen and halogens. Then halogens are chlorine, bromine, fluorine, and iodine. So from this structure now, I'm going to remove hydrogen and halogen. I will remove hydrogen and halogen. Then when you remove hydrogen from one carbon atom, you remove halogen from the other carbon atom. So you cannot remove both hydrogen and chlorine from the same carbon atom. So if I remove hydrogen from here, or if I eliminate, let me use the word eliminate. If I eliminate hydrogen from this what? From this side, so I will eliminate chlorine from this side. That is, you remove chlorine here, you remove hydrogen here. So by the time you remove hydrogen here and you remove chlorine here, so this hydrogen will combine with OH. So this KOH will decompose into K and OH. So hydrogen will combine with OH to give us, we have added KOH. So when this hydrogen combine with OH, so reaction between hydrogen and OH will give us H2O. That is 2 hydrogen plus 1 oxygen will give us H2O. So we are going to remove 1 water molecule minus 1 water molecule now when KOH reacts with this. Then chlorine will also combine with what? With K. Reaction between K and Cl will give us KCl. So there will be removal of what? KCl from this structure. So this hydrogen gone, then chlorine gone. So our structure will remain still with 2 hydrogen atom, then the second carbon atom with hydrogen and chlorine. So when we remove this hydrogen and chlorine now, so we'll be left with 1 carbon atom with 2 hydrogens. We have removed this chlorine. So hydrogen at this side. So hydrogen at this side. Then the second hydrogen here. The second hydrogen here. Then a single bond. A single bond followed by this carbon atom. Followed by this carbon atom. So we have removed this hydrogen. So this hydrogen is no more there. So it will remain hydrogen and chlorine from this second carbon atom. So attach your hydrogen, then attach your chlorine. Then don't forget that in organic chemistry, each carbon atom, one carbon atom must be surrounded with 4 chemical bonds. So let's check if the number of chemical bonds that surrounded each atom is complete. So let's check. 1, 2, 3. So this one remains what? It remains one more chemical bond to complete. So you add one bond. You add one chemical bond to this structure. So carbon 1, 2, 3, 4. 1, 2, 3, 4. So complete. But that is not where we are going. Don't forget that we want to prepare what? We are preparing ethyne. We want to prepare ethyne. We are still going to C2H2. So from this our structure now, we have chloroethene because there is presence of double bond in this structure. We have chloroethene, chloroethene. So the next one, we are going to add our what? Our soda amide. That is NaNH2. So let's add NaNH2 to this structure. Let's add NaNH2 to this structure. So from the second one now, we have removed one halide from here. Don't forget that we are removing 2 halide. That means 2. So we have removed one HCl here. So we are going to remove another HCl. So remove hydrogen here. Then you remove chlorine here. So when you remove hydrogen here, this hydrogen will combine with what? With NH2, with amine, to give us NH3. So when hydrogen combine with NH2, will give us NH3. Then chlorine will react with what? With Na. Chlorine will react with Na to give us what? NaCl. So we have removed hydrogen and chlorine, and hydrogen has combined with NH2 to give us ammonia. Then chlorine combined with what? With sodium to give us what? Sodium chloride. Now this structure will remain 2 carbon atoms with 2 hydrogen. So we are left with carbon double bond, then one hydrogen at this side, then the other hydrogen at this side. But this structure is not what? It's not complete. It is not complete. So let's look at this structure. Each carbon atom, one carbon atom must be surrounded with 4 chemical bonds. 1, 2, 3. Then it needs one more, so we add one double bond to complete 4. So 1, 2, 3, 4. 1, 2, 3, 4. So what will be the molecular formula for this structure? How many carbon atoms? 1, 2. 2 carbon atoms, that's C2. How many hydrogen? 1, 2. 2 hydrogen. So therefore, we have produced what? We have produced ethyne. C2H2 is the molecular formula for ethyne. C2H2 is the molecular formula for ethyne. Then let's move to the second part, number 2. Number 2 method of preparation of preparing alkyne. So the second method, we are still on method of preparation of alkyne. So the second method of preparation of alkyne is called tetrahalide. Which is known as dehalogenation. Then we are going to add four halogens, to the structural formula of alkane. Don't forget that our starting material is what? Is alkane. Our starting material is what? Is alkane. So tetra means four. Tetra means four. So there will be addition of what? Four halogens to what? To a corresponding alkane. So what I mean by corresponding alkane is that if you want to prepare a time, if you want to prepare a time, you use what? You use ethane as a corresponding alkane. If you want to prepare a time, you use ethane. So I'm going to add four halogen atoms. So to a corresponding, I want to prepare ethane now, so I'm going to use alkane, that is ethane. I will use ethane. So ethane is the second member of alkane with single bond. Then add four halogen atoms. Then I use chlorine here. So we can also use bromine. You can use any what? Any halogens member. You can use bromine. You can use iodine. Then this time around, I'm going to use bromine. I will add four bromine atoms. Four bromine atoms. Four bromine atoms. Then fill others with what? With hydrogen atoms. So these four bromine atoms make it to be what? A tetrahalide. Tetrahalide. Then the halogenation. De means remover, then halogen. So remover of halogens. So I'm going to remove all the halogens totally. So you remove all the halogens totally in the presence of alcoholic zinc. In the presence of alcoholic zinc. So reaction will take place when alcoholic zinc is added to this what? To this haloalkane. The reaction will take place in the presence of what? Of alcoholic zinc. Now, what will be our product now? Now, eliminate all the halogens that are present in this structure. That is, remove all these halogens. Remove the four halogens. So if you remove Br, so it will give us four bromine. Then our structure will remain what? Hydrogen, carbon, carbon, hydrogen. So we'll be left with the two carbon atoms with hydrogen at this side, then the other hydrogen at this side. So when we remove all the what? All these halogens. Now, this structure is not what? It's not complete. Why? Because each carbon atom must be surrounded with four chemical bonds. So we have one here, one here, one, two. It remains two to balance. 3, 4. So 1, 2, 3, 4. 1, 2, 3, 4. So this structure is complete now. So what is the molecular formula for this structure? C2, 2 carbon atom, 1, 2, 2 hydrogen atom, H2. So we have prepared what? We have prepared a time from tetrahalide, remover of what? Of halogens. Now, the bromine atoms here will then react with what? Zn. Then don't forget that Zn is 2 plus. Then bromine is -1. Is minus. Then for this charge, to cancel this charge, for the two what? For the two ions to come together to form a compound. So the positive must cancel what? The negative. Then chlorine is minus. Minus means -1. Then +2. So +2 cannot cancel -1. So we have to multiply this one by 2. So by the time you multiply bromine by 2, so it will be -1 times 2 will give me -2. Then +2, yeah, we cancel this -2 down. So Z then we combine with Br to give us plus Zn, then Br2. Zn So from this our structure, from the reactant side, we have 4 bromine from the reactant side, but at this side we have 2 bromine, so we have to put 2 here to balance our chemical equation. The zinc is 2 at this side, so we put 2 here to balance our chemical equation. So from there, so we have produced what? Ethyne. This is ethyne. So that is the second method of preparing what? Alkyne. The second method of preparing alkyne. So let's talk about preparation of alkyne from calcium dicarbide. Preparation of alkyne from calcium dicarbide. Preparation of alkyne from calcium dicarbide. That is number 3. From calcium dicarbide and cold water. So reaction between calcium dicarbide and cold water will give us what? Will give us ethyne. We want to produce ethyne. Reaction between calcium dicarbide and cold water will give us ethyne. Then what is calcium dicarbide? That's calcium. Then dicarbide. Carbide is from carbon. That is, di means 2. That's 2 carbon atom. So calcium dicarbide is CaC2. Then plus what? Plus cold water, H2O. Then I want to explain how this calcium dicarbide, where this calcium dicarbide is derived from. I want to explain the derivation of what? Calcium dicarbide. We derive calcium dicarbide, although it's not part of the class. We derive calcium dicarbide from limestone. Then the chemical formula for limestone is CaCO3. So when limestone decompose, that is CaCO3, when it's decomposition of CaCO3 under it will give us CO2. It will first liberate what? Carbon 4 oxide. So when you remove CO2 from this structure, it remains Ca and 1 oxygen. Because I've removed 2 oxygen, it will remain 1 oxygen here. So our product will now be CaO plus what? Plus CO2. Then the CO2 will escape in form of gas. Then calcium is what? Is solid. So when calcium reacts with coke, carbon is coke. That is, coke is what? Is an amorphous of carbon. Coke is an amorphous of carbon. So reaction between calcium and coke will give us calcium dicarbide. That is, calcium will combine with C to give us CaC2. Then plus oxygen will combine with carbon to give us what? CO, carbon 2 oxide. So the carbon 2 oxide will escape in form of gas to produce what? Calcium dicarbide. So calcium dicarbide is produced from what? From limestone. The original what? The original material, the starting material is what? Limestone. Now let's come back to preparation of what? Of ethyne from calcium dicarbide. Let's come back to preparation of ethyne from calcium dicarbide. So CaC2 plus H2O. CaC2 plus H2O. What will be our product? Calcium, which is positive. Calcium will combine with hydrogen to give us calcium will combine with oxygen. To give us CaO. That is calcium oxide, which is called what? Quicklime. Then carbon will combine with what? Hydrogen. To give us what? C2H2. Then C2H2 is the molecular formula for ethyne. So from reaction between calcium dicarbide and cold water, we have produced what? We have produced ethyne. This is solid. Then this is liquid, while this one is what? Is solid. So we have produced ethyne. So we've come to the end of today's class. Remember to subscribe to Royal Learning Channel. Share this video with your friend and comment. See you in my next class. Love you. Bye.